Hey everyone! In this episode, we will be talking about middleware in Hot Chocolate. What middleware is and how you can use middleware to completely customize how Hot Chocolate works. Things like pagination, filtering, sorting is all based on middleware. If you like our content, please hit the like and subscribe button below the video. And with that, let's dive right in. So today is a premiere because I'm not starting with code. I first will have a couple of slides to just get you into the topic here. So there are three kinds of middleware that are important with Hot Chocolate. We have transport middleware, and that's actually not something Hot Chocolate specific, it's ASP.NET Core specific. So in ASP.NET Core, we can write transport middlewares to handle certain kinds of requests. And when you use the map GraphQL method on the web application builder, you're actually applying a middleware. We're not looking into transport middleware in this episode and focus on the latter two. The second important middleware for Hot Chocolate is a request middleware. And that is how the overall request execution in Hot Chocolate is done. We are invoking a request pipeline, and each middleware in that pipeline has a certain kind of job. We will look at what that means in a couple of seconds. Thirdly, there's a field middleware. And a field middleware you have certainly already touched if you used paging or you used filtering or any kind of these data middlewares that you apply on top of your resolver. Okay, let's dive in the request middleware first. So the request middleware or the request pipeline defines the overall GraphQL execution. And if we look at the default request pipeline, we can see there are a ton of middlewares involved. Actually, there are actually more if we looked at the current implementation of Hot Chocolate. But let's focus maybe on the core middlewares here. And there are two middlewares at the beginning of the pipeline that just make sure that everything runs fine in Hot Chocolate. So the first is a diagnostic middleware, which produces diagnostic data for the OpenTelemetry events that we provide. The second middleware will capture any exception that could occur during executing all the rest of the middlewares. It's essentially a make sure that nothing goes wrong middleware. And if something goes wrong, reproduce still a valid GraphQL execution error. Okay, if we look at the rest of the pipeline here, we actually can see the GraphQL spec behavior. Like we have here the pathing of the request document, the GraphQL query. There's a validation that makes sure the document is semantically correct. Then we have the operation compilation here, which is not in the spec. In the spec, we would have something like resolve operation. So just making sure that we take the right operation to execute. In Hot Chocolate, we compile it because we have a two-phase execution. After that, again, we could align that with a spec. We have queries variables that make sure that the variables that we have for this request are correct, and we bring them into the form that we need to execute our request. Last but not least, we have a middleware that executes the actual GraphQL request. Okay, that is essentially the core pipeline. What we want to do is customize it a bit. And for that, let's go into some code. So there was someone on our Slack channel a couple of days ago, and he wanted to implement a custom timeout for certain operations or for certain queries. So his use case was that the default timeout is actually fine that we have in Hot Chocolate, but he wanted for a couple of specific queries to allow a higher timeout. So allow essentially a longer execution of the query. And that is actually the perfect thing to put in the request pipeline. And we will do that. So first we have a very simple schema here, the books and authors example I often use. But this time we have a very expensive resolver on our books entity. And we're gonna craft a query, and this query will be expensive, and we want to make sure that it still executes fine, but only this specific query. Okay, so in our default setup, we have a standard GraphQL server here. We registered our root query type, and then we specified that our default timeout actually is 1 second. So let's start our server, and I'm running here .NET Watch, so we don't have to recompile and restart it manually all the time. And we can just dive into Banana Cakepop here to try out a couple of queries before we get started. So I already prepared for our demo here a document. And what we do first is just run a query to fetch a book. And that just runs fine. But what if we asked for the expensive field that takes 5 seconds? Then we would wait and wait and wait, and at one point get a timeout. So actually, why did we have to wait so long here? Is because we didn't honor the cancellation token. So it would still time out, but our request engine couldn't abort that. So it's always important, if you have async work, that you pass on the cancellation token. And with that, it should rebuild. We can try that again. And this time we execute it and we get a much quicker abortion. So that is the timeout middleware that is in the default pipeline. Okay, let's have a look at the default pipeline. So in order to explicitly apply the default pipeline, we do it by default, so you don't have to do it, but to get a grasp of it, we could say use default pipeline. There are more pipeline than just a default pipeline. So if you, for instance, use persisted queries, there would be a use persisted query pipeline. So depending on your use cases, there are already pre-configured default pipelines for certain specific use cases. Okay, but we just keep the default pipeline. So we want to modify that. So how would we do that? How do we know what's even in there? So a good thing is to have a look at it. And you can see this is a default pipeline. You can already see here is also another pipeline, the use persisted query pipeline. You can see that actually we chain a lot of pipelines together here. In our instance, we want to use the default pipeline, and we cannot get there. The default, the decompiler doesn't recognize this method somehow, but we can search for it in the document. And here we have it. So the default pipeline has all the pipelines I showed you in the beginning. What I hid essentially as a fact is that there is also a timeout middleware. Okay, this is in a different form here, so we cannot just copy it. So I already prepared that, and we can just use the default pipeline here. And that is what the default pipeline essentially would look like in such a configuration. We use the instrumentation pipeline, that's the diagnostic I showed you in the beginning. Then there is the exception pipeline. We have the use timeout pipeline, that's the one we want to replace. And then we have all the other pipelines. So first off, let's understand what a middleware is. It's very simple, but it takes sometimes time to understand it. So a middleware is essentially something very, very simple. It's a factory pattern. So we first have the factory part. This is the first delegate here. This is to create the middleware. And what we get passed in here is the next middleware in the pipeline. So the next here at this point points to use instrumentation, so the diagnostics pipeline. And the second part here is the actual middleware. So why do we do that? because by having such a factory, we get the next invocable middleware here, and then we can write logic around it. So we can write logic in front of next, so before the next middleware is executed, and afterwards. And depending on our use case, we could enrich the context for the latter middlewares, or we could use something that the latter middlewares produced and do something else with it. So let's, for instance, run this little middleware here. If we run that, we print out onto the console the GraphQL request document before we invoke next and after we invoke next. Let's just do that. So I'm running this query again, but let's get rid of the wait here and then have a look at our console output. So we can see before we invoked our middleware here, nothing was there. So the document wasn't even passed. That's why the document is null at that point. But after next was invoked, we can see that a document was passed and we were able to print it to the console. And that's because you can see down here is the pass document middleware. Okay, so if we move that to after the pass document middleware and run this query again, then we can see that before we get the document and after we get the document. Okay, so that's very simple, this middleware pattern, but it's very, very powerful. Let's have a look at how we can actually write or change the used timeout middleware to have custom timeouts for certain requests. So what we would do first is look at the timeout middleware that is in Hot Chocolate. And we can see it's actually a class in this instance. So we could let's just grab that and copy that into our program CS here. Okay. There are a couple of imports missing. So let's import the usings here. And yeah, there's debugger that is missing. Okay, that looks good. Next is not imported, and that's because ASP.NET Core has called the request delegate the same as Hot Chocolate, or actually we did. We copied the name of the ASP.NET Core middlewares. Because when I started building Hot Chocolate, I looked at the bedrock patterns that David Fowler laid out, and a lot of these patterns are actually used in Hot Chocolate. And that is one of them. Okay, so let's reformat that and then let's get to it. So at the moment, this middleware works that when we are debugging, so if there is a debugger attached, we actually don't have a timeout, because it would be annoying if when we are debugging just a thing and looking things up and then the timeout hits and kills our request all the time. So the default middleware will not have a timeout if the debugger is attached. That's nice. So the second thing is that we create a cancellation token source here with a timeout. And we take the timeout from the options. So we inject the options here. And we also inject the next delegate. So if we use a class form for middleware here, we inject the next delegate into the constructor. Okay, so we are using the timeout here, but if we just use this token source to cancel the request, we wouldn't get notified if the ASP.NET Core middleware already signals to us that the request is canceled. So that's why we create another cancellation token source here that combines the original request abort token from ASP.NET Core with our timeout token. Last, we assign the new combined token to our request aborted property on the request context. So we are updating the context with this new cancellation token, and then we have this new cancellation token behavior. So we are either cancelled if ASP.NET Core says the request was aborted, or if the timeout is hit and the timeout token signals that the request should be cancelled now. So that's super awesome. It will work and we would be happy with that. Okay, so we still have two squiggles here, and that's where we produce the error result. And we can just put in our own error result. Let me just copy it over. I have that on the sides here. It's pretty simple. So you can use a query result builder to create a valid GraphQL result. And then there is a helper method called create error. And then we can pass in one or more error messages here. And we just simplified it. It's timed out. We display the timeout and an error code that we could filter on. Okay, let's put that in both places here and be happy with that. Apart from just reformatting a bit, making it work in our code, we haven't implemented any special behavior yet. So what we want to do is only have the standard timeout for unknown queries. So we kind of want to have a hash set or something that identifies queries that are treated special, like having a longer timeout. So first, let's introduce the longer timeout. So we have a time span here that is the standard timeout. So let's call that standard timeout then. And then we have a second timeout. Let's call that extended timeout. And that is actually static. And we give it, let's say, 30 seconds. From seconds and say 30. Okay, how do we identify these queries? So it's pretty easy because Hot Chocolate actually will hash these queries. And we can use that. So let's introduce first a new hash set here, and we call that special queries. Okay. You might have better ideas for the name here. Okay, so next thing is, if our special queries contains the hash of the current request, so we can look in the context, there's a request object. That is what we get from the transport layer. And there we have a query hash. And if that query hash is being provided, so let's just make sure we have a hash. If is not null. And we have that hash in our hash set. Then we want to use our new special extended timeout. Okay. That's good. That should work. But how do we get this special timeout? So I'm doing it very cheaply here. Let's collect that timeout and print it out. So we do a console write line here. That's not the proper way. You could record that, look it up in your diagnostics, whatever. Don't print it out. But I will, because we are just doing demo code here. So context dot request, and we're just gonna print our query hash so we can collect them. Let's hook that up. So here's our timeout middleware, and we now put in that place use request. That signals that this is a request middleware. You can see we also could have here field middlewares, but let's use the request middleware and put in the timeout middleware that we created. Okay. Does it work? I don't know. This is really done live here. Okay, this is our first query. It runs. Now we do our timeout query, and that's the one we want to capture. Gets a timeout, but you can see down here we captured the hash. And now we're gonna put that in our dictionary. Not in our dictionary, but in our hash set. Let me put that in here. It recompiles. Yeah, it's back. Go back here, run that. It runs forever. We get our result because this is exempted from the timeout now. We also get standard results. But if we, for instance, set weight and author, right? Then it will, after 1 second, time out again. And you can see here, I did a mistake with my error message because this should not be timeout, the token, it should be the standard timeout. With this, we are done with our request middleware. And let's head to the next topic, and that is field middleware. And field middleware you most certainly already used. So this is a resolver, our standard query root type and a single resolver get assets. And we're returning here a list. And where I think you already used the middleware is when you applied the use paging attribute here. But you could have more middlewares, like if you were using the data package and use something like use filtering or use projection, you're actually also using just middlewares. And if we look at the resolver here, this is our pipeline. Use paging at the top is invoked first, and then next is projection, next filtering, next sorting, next our resolver. Our resolver is also a middleware in that pipeline. And this naturally is the annotation-based approach. If we look a bit at the middleware, at our simple middleware with the use paging and get assets, use paging will just invoke next first, and then get assets will return the queryable as a result on which use paging applies the slicing. So if we look at the larger pipeline with all the data middlewares, we can see that all of them first just refer to the next item in the pipeline. And we again end up at the resolver, which will put the queryable on the result property. And then from there on, we will apply for each of the middlewares an expression that will translate then to the native database query at some point. So far we just talked about annotation-based, but actually in Hot Chocolate we also have the code-first approach and the schema-first approach. And the code-first approach is beneath everything, and we will see that as we build the middlewares. The code-first approach would look something like this, where we have a class that represents the GraphQL type, and this type is an object type. So we say object type of query. We still have our query type in C# here. And then we have our middleware chained into the configuration of the field here. We also could have a slimmer version of that, where we don't have a class. We just have a resolver down here, which we express with the delegate. And then you also can see proper the pipeline again, where use paging is invoked first and at the end the resolver. Again, this could also work in schema first, where we could use directives as a representation, kind of like the attributes in C#. This actually is supported in version 13. You could build it in version 12, but our data middlewares are only translated to directives in version 13 out of the box. What you could do in version 12 is having the SDL to declare your type and then put the transformation attributes on top of your resolver. Okay, let's have a look at some code and implement a little middleware. And what we want to do is implement a very simple middleware that applies a to-upper casing on strings. So when we apply that middleware to a string resolver, we will get a to-upper string out of it. So I'm getting rid of our request middlewares here. And then we're going to introduce a new middleware for our field. And as said, code first is beneath everything here. And that means we need to write the middleware for our code first approach. And we're gonna do that by introducing an extension class, a static class. And into that, we're gonna create an extension method which extends the iObject field descriptor with a new method called useToUpper. And there we use a middleware. And again, it works the same like the request middleware. So we have next, this is the factory part, and this is the actual middleware. And in order to apply it to upper on our resolver result, we will first invoke the next middleware. And then when we get back control, we will look at the result of our resolver context. And if it is a string, then we will update the result with an upper string. So very, very simple. Let's reformat that. And we're basically done. If we used code first, we could just introduce a book type now and then use our new extension method here. And if we registered that and type book type, then it would already work. So let's go here and execute it, and you can see we get a toUpper result. But in our case, we used annotation-based. So how do we do it in annotation-based? First, let's get rid of the book type here and go back to our program CS. And we're gonna introduce an attribute, and we call these attribute descriptor attributes because they let you intercept the descriptor, the configuration object of the annotated resolver or annotated class. You can actually put it even on enums, and we will intercept the enum value descriptor there. But in this case, we are annotating the object field, and so we're intercepting the object field descriptor. So let me import the namespaces here quickly. And then you can see we have the descriptor here. And we will just do descriptor and then use toUpper, I think. And then we can already use our attribute on our book title here. Use toUpper, and we have a nice middleware attribute. There's one thing, and that's about order, because in C#, actually there is no order with attributes, or it's not guaranteed, depending on how you compile it. So in order to preserve the order here, we did a little trick. So you're gonna create a constructor for your, it's only for middleware attributes where order matters. And there you're gonna inject the line number of where this attribute is. So if we are here, it will automatically now inject 18. The compiler will write 18 into our constructor argument. And we pass that along to the order property of this attribute, and then our schema builder will know when to apply that. So there's one issue here. You shouldn't inherit middleware attributes. So all the other attributes that don't need order is actually not a problem, but middleware attributes shouldn't be inherited. I would even argue not to inherit these configuration attributes at all. Put them always on top. Okay, let's try it out. Let's run it again. But before we can run it, we annotated it here now, but we need to get rid of our book type registration up here. So with this, our server is recompiling, it's back, and we can go back to banana cake pop. And then we have the old result. If we run it again, we get the same result. So our middleware works now as an annotation. One last thought here. You can also apply other configurations here. We could, for instance, rename the field. Like we could say, okay, the actual name of the field we annotated should now be foo. The server is recompiling. Let's go back here, refresh that, And then you can see that is actually wrong because now it's called foo. Why am I saying that? I just want to make the point you can use descriptor attributes not only to apply middlewares, you could also apply configuration. Essentially, you package fluent configuration instructions into a single attribute, kind of as a package. And then you can apply it everywhere in your schema. So reusable packages of configuration. I will do another videos on descriptor attributes and type interceptors, which goes more into depth how to rewrite and intercept configurations. I hope you learned a ton of new things. This was really a deep dive into middlewares. I know it's a very abstract topic, but it enables you to do so much more with Hot Chocolate. And a lot of questions and needs that user express on Slack often can be solved with such middlewares. Please help growing our project and give us a star on GitHub. And if you like our content, please hit the like and subscribe button below the video. And with that, I see you next time.